Example 2, given triangle ABE similar to triangle ACD, find the value of x. In this variation, we see that we have a small triangle encapsulated inside a bigger triangle. So my strategy here is going to be to separate these. So I'm going to redraw this part right here. So this is the small triangle. I'm going to go ahead and redraw it here. So I'm going to get a triangle AEB. Okay, now that I've taken this small triangle out, I'm going to get rid of this part right here. This is not needed anymore. And I can also get rid of B and E. So let me get rid of these ones as well. To get the lengths of the big triangle, we saw that, well, actually let me bring back that little stick here. And here we see what I've highlighted in turquoise. This length is equal to 10. And this part in green is equal to x. So if I want to get the whole thing, which is the whole red thing, I'm going to have to add these two values. So this length is 10 plus x. The same thing here. The whole length here is going to be 15 plus 6. So I'm going to go ahead and get rid of these two. So 10x, 15, and 6. And get rid of this part. And I'm aware that you don't have the luxury of doing that, but just follow along so you can get the idea. So now these two triangles are similar, and here we can actually just do this by inspection since they're already facing in the same position, but just for practice, here we can see that AB corresponds to AC. So AB is right here, and this corresponds to AC. And then BE, which is right here, or corresponds to CD, which is right here. And then lastly, AD corresponds to AE right here. So let's begin by getting one pair of corresponding sides. So we know that AC corresponds to AB, so we can rewrite this as 10 plus x all over 10. And since the triangles are similar, this means that this ratio must equal another ratio of another pair of corresponding sides. So here I'm going to use this one, AD corresponding to AE. So let's set that equal to AD, which is 15 plus 6, all over AE, which is 15. And I have a proportion, so I can apply cross multiplication. So I'm going to do 15 times 10 plus x, and that's going to equal 10 times 15 plus 6, which is 21. I'm going to split up my equation. On the left hand side, I'm going to have to apply the distributive property. So the 15 multiplied to 10, the 15 is going to multiply to x. So 15 times 10, that's 150. And then 15 times x, that's 15x. And remember, whenever you distribute the operation in the middle, that one stays the same. Unless if you have a negative and there's a minus here, then it's going to switch. But here, this is going to equal 10 times 21, which is, well, 210. So we have 210 here. Now the objective is to isolate x, but we have to get rid of this 150. Here we have a positive 150, so the inverse operation would be minus 150. We have to do that to the right hand side as well. 150 minus 150, that's 0, so we get 0 plus 15x on the left. And then 210 minus 150 is the same thing as 60. 0 plus 15x, that's 15x. And then this still equals 60. The inverse operation of multiplication is division. So we divide by 15 on the left, divide by 15 on the right. 15 over 15, that's 1. So we get 1x equal to 4. 60 divided by 15 is 4. So we get 1 times x, which is x, and then equals 4. And there you have it.